Alright, so in this video we're going to cover factoring. We're going to review 3 different types of problems that can come up for you to factor. So the first thing you should look at when you look at the equation is a. So a is, in standard form, we have ax squared plus bx plus c. So a is the coefficient out front. Here there's a 1, so we say a is equal to 1. Whenever a is equal to 1, you just go ahead and you start factoring right away. Now, by factoring, we mean split it up into 2 binomials. So we need something times something to get us back to this original polynomial. If a is 1, we want 2 numbers that multiply to get us negative 48. So we need to multiply to negative 48, and we need to add to get negative 2. So those same 2 numbers need to multiply to get negative 48, add to get negative 2. Now since a is 1, I'm just using x times x. Alright, so 48. Well, I know factors of 48 are 1, 2, 3, goes in there, 4, 5. Again, we can keep going around and figure out the factors. But think of them in pairs instead. Well, 2 times 24. Well, that's not going to get me to 2. Maybe 3 or 4 times 12. So 4 times 12. If I add or subtract those, I don't get negative 2. Maybe 6 times 8. Well, they have a difference of 2, but I need negative 2. So maybe I need to have negative 8 and positive 6. Plus 6, that equals negative 2. So again, this is some of the guesswork you can do off to the side. So I need negative 8, and I need positive 6. And again, here's where you can go ahead and do a check step. So checking, you're going to multiply the insides. So negative 8 times x is negative 8x. And multiply the outsides. So 6 times x is 6x. Add those together, I get negative 2x. Well, that matches with the middle there. So I did that correct, because I know x times x gives me x squared, and I know negative 8 times 6 gives me negative 48. So again, now my factors of this problem are x minus 8 and x plus 6. So that would be that problem completely factored. Alright, so now the next problem. What happens when a is not equal to 1? So here we realize we have a equals 6. Which is not 1. Well, the first thing you should do is you should try to take out a GCF. So that's your greatest common factor. So greatest common factor. So what that really means is try to divide the equation by something. Well, 6 can divide by 6. Well, I don't think that goes into 57. I should go ahead and try that. And it ends up that 6 does not go into 57. So 57 divided by 6 ends up being 9.5. So then that won't work. So we need to try something else. Well, maybe dividing the whole equation by 3. Let's see if that works. So I divide by 3. 6 divides by 3. 57 divided by 3 is 19. So that works. And 105 divided by 3 is 35. So that works. So take out a 3. What am I going to be left with? Well, 6 divided by 3 is 2x squared. 3, we said that was 19 minus 19x. And on 105, that was positive 35. So it's whatever's left by dividing by 3. Alright, so now we need to factor this. Well, I can't take 2 out, so a is still not 1. Well, that just means that you need 2 numbers to get to x squared. So think about 2x and x. And again, you can kind of switch that. So now you need to multiply to get leading coefficient. And this is where kind of guess and check comes into play. So now step 3 is guess and check. So I still need 2 numbers that multiply to get 35. but I need to get a negative 819 in the middle. This 2 is going to change things, though, because I'm going to multiply 2 times whatever's there. The negative tells me I need 2 negative signs because I need a positive 35. So I should probably try 5 and 2. Or, well, 5 and 2 doesn't give me 35. But 5 and 7 would work. Or dividing by something else. So let's try 5 and 7 and see what happens. I'm going to put 5 here and 7 here. So again, do your check step. So check. And that 3 does come down the whole time. So I get negative 5x. 2 times, that's negative 14x. Add them together, you get negative 19x. And that matches with that middle term there, so we did do it correctly. So my final solution to factoring this problem is 3 times 2x minus 5 times x minus 1, or 7. So that is the final answer here. Now again, you may not have picked those factors to start out with. You could have put 7 here first and put 5 here instead. Again, it just kind of depends on how you solved the problem, and that wouldn't work, and then you would have to try rotating them. Or you may have tried positive and negative, or negative and positive, or 2 positives. So again, checking to make sure you get that inside number is critical. The last type of problem is when there's the missing x, is what I call it. So missing bx. If you're missing that bx term, what you should do is look for perfect squares. Well, what are the perfect squares? That's your 1, 4, 9, 16, and so on. Keep going. That's 1 squared, 2 squared, 3 squared. Well, you should realize that 49 is 7 squared. So this is actually a case that we call a difference of squares. So difference of squares. When you have a difference of squares, all you're going to do, again, there's a 1 here, and a 1 is actually a perfect square too. That's important, that that first one be a perfect square too. All you're going to do is you're going to take the square root of 49, so that's plus and minus 7. So to factor this, I need x plus 7, and I need x minus 7, because that will make the middle go away. And again, that will be shown by our check step here. So check to see it works. 7x, negative 7x, add them together, you get 0x. Well, there was no x, again, missing bx. So 0x, that checks out. So again, my solution here is x plus 7 and x minus 7. And that ends up factoring nicely. So now go ahead and try the ones in your Summer Mastery packet, and bring any questions to school that you still have.